Hello student, good morning. I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss colloids around us. Last class I have discussed electrophoresis, coagulation of lyophobic salts, coagulation of lyophilic salts, protection of colloids and emulsions. Now I am going to discuss colloids around us. Most of substances we come across in our daily life are colloids. The meals we eat, the clothes we wear, the wooden furniture we use, the houses we live in, the newspapers we read are largely composed of colloids. Okay. Now, other things. I want to tell some examples. Interesting examples. First examples, blue color of the sky. Blue color of the sky. Dust particles along with water suspended in air scatter blue light which reaches our eyes and the sky looks blue to us. This is due to colloidal solution, due to colloids. Again, I am telling you, dust particles along with water suspended in the air scatter blue light which reaches our eyes and the sky looks blue to us. This is the first example. Second, fog, mist and rain. When a large mass of air containing dust particles is cooled below its dew point, the moisture from the air condenses on the surfaces of these particles, forming fine droplets. These droplets, being colloidal in nature, continue to float in air in the form of mist or fog. Clouds are aerosols having small droplets of water suspended in air. On account of condensation in the upper atmosphere, the colloidal droplets of water grow bigger and bigger in size till they come down in the form of rain. Sometimes the rainfall occurs when two oppositely charged clouds meet because they neutralize the charge and precipitation takes place. It is possible to cause artificial rain by throwing electrified sand on a spring or spraying. It is possible to cause artificial rain by throwing electrified sand or spraying a salt carrying charge opposite to the one on clouds from an aeroplane. Clouds may be sometimes positively charged. Then you have to throw negatively charged electrified sand or spraying And if it is a negative, then positively charged electrified sand or spraying a sol we have to throw by aeroplane. Okay, and so it is possible to cause artificial rain by throwing electrified sand or spraying a sol carrying charge opposite to the one on clouds from an aeroplane. Now, third example, food articles, milk, butter, halwa, ice creams, fruits juice, etc. are all colloids in one form or the other. Next, that is the blood. Next example is blood. Blood is a colloidal solution of an albuminoid substances. The septic action of alum and ferric chloride solution is due to coagulation of blood forming a clot which stops further bleeding. That I am talking about the blood. Blood is the best example. It is a colloidal solution of an albuminoid substances. The septic action of alum and ferric chloride solution is due to coagulation of blood forming a clot which stops further bleeding. Next example is soils. Fertile soils are colloidal in nature, in which humus acts as a protective colloid. On account of colloidal nature, soils absorb moisture and nourishing materials. Next example is formation of delta. Formation of delta in ocean, in sea, particularly in sea, you might have seen, or rivers also, that there will be formation of delta. How delta is formed in sea or rivers? That is due to colloidal particles or due to colloidal action. Okay, this happens due to the colloidal process. How? Now I am telling you. Formation of delta. River water is a colloidal solution of clay, and sea water contains a number of electrolytes. When river water meets the sea water, the electrolytes present in sea water coagulate the colloidal solution of clay, resulting in its deposition with the formation of delta. Because electrolytes present in sea that neutralizes the charge of clay present in river water. In river water, clay is there. Clay has some charge, and that charge in clay, charges present in clay is going to be neutralized by electrolyte present in sea water. And when charge will be neutralized, then clay will coagulate and it will form delta. This I have told you some examples of this colloidal in our you can say surroundings, okay, or in nature. Now I am telling you some applications of colloids. Some very important applications are there. I will discuss that. Colloids are widely used in the industry. Main use of colloids are in industry. First use I am talking about electrical precipitation of smoke. Smoke is a colloidal solution of solid particles such as carbon, arsenic compounds, dust, etc. in air. These particles will be present in air, correct? These particles are present in air and it forms colloidal. Okay. Then smoke is the example of colloidal solution. The smoke before it comes out from the chimney is led through a chamber containing plates having a charge opposite to that carried by smoke particles. The particles, on coming in contact with these plates, lose their charges and get precipitated. The particles thus settle down on the floor of the chamber. The precipitator is called Cottrell precipitator. Cottrell. Cottrell precipitator. Okay, means for the precipitation or for coagulation, what is the requirement? That on the colloidal particles, whatever charge is there, that charge should be neutralized, because due to their charge, they are in colloidal form. Because due to the charge, same charge, repulsion will be there. That's why that charge must be neutralized. Then all particles will come together and it will precipitate. It will come down. It will coagulate. Okay. Next example I am telling you, purification of drinking water. The water obtained from natural sources often contains suspended impurities. Potash alum I am talking about, K2SO4, Al2SO4 whole 3, 24H2O. This is the chemical formula of alum. K2SO4, Al2SO4 whole 3, 24H2O. Then this, how drinking water is purified? The water obtained from natural sources often contains suspended impurities. Alum is added to such water to coagulate the suspended impurities and make water fit for drinking purpose. Alum means K2SO4, Al2SO4 whole 3, 24H2O. These are actually salt, means have ions, charge. Ions means charge. That's why it will neutralize the, you can say, charge present on the colloidal particles in water. In water, colloidal particles are as impurities. They have some charge. Then this potash alum will neutralize the charge and suspended particles will settle down. You can filter it, and that water, after filtering, you can drink it. Okay. Now third example I am telling you, medicines. Most of the medicines are colloidal in nature. For example, first example is argyrol, ARGY, argyrol, ROL. Okay, argyrol is a silver sol used as a eye lotion. It is used as a eye lotion. Colloidal, actually this second example I am talking about, colloidal antimony. Colloidal antimony is used as a curing one disease that is called kala jar, high fever, kala jar. Okay, there this antimony is used, colloidal antimony. Okay, it is in the colloidal form, and it is used in curing kala jar disease. Colloidal gold is used for intramuscular injection. Okay, it is used as an injection, intramuscular injection, colloidal gold. Now, next example is milk. Already I discussed milk of one milk, common milk, already I told you. Now, this is the milk of magnesia. Magnesium hydroxide. Okay, milk of magnesia, and emulsion. This is actually emulsion, is used for stomach disorders. If some problem is in their stomach, that time milk of magnesia is used. Now, colloidal medicines are more effective. Colloidal medicines are more effective because they have large surface area and are therefore easily assimilated. Okay, due to the large area, surface area, it is easily, or you can say this due to large surface area, it is more effective, or you can tell easily assimilated. Now, other example I am telling you, that is tanning, 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 animal hides. Might be knowing animal hide, HIDES. Okay, animal hides are colloidal in nature. Correct? Animal hides are colloidal in nature. When a hide which has positively charged particles is soaked in tannin is a chemical, type of chemical, is soaked in a tannin which contain negatively charged colloidal particles. Tannin is a substance, you can tell, just like chemical substance. It has negatively charged colloidal particles in particles form. Then this hide has a positively charged, has a positively charged particles. Okay, animal hide. And when it is soaked in tannin which contain negatively charged colloidal particles, mutual coagulation takes place. Okay, then both will come in contact, then mutual coagulation takes place. This results in hardening of leather. Leather is formed by tanning process. Okay, by tanning process or by tanning, leather is formed because now it precipitated or coagulated, then all particles will come very close to each other. That's why hardening will take place. Leather will become hard. This process is termed as tanning. This process, that leather formation or hardening of leather, This process is termed as tannin. Okay. Now chromium salts are also used in place of tannin. If tannin is not there, and if you want to make this leather, or if you want to make this leather hard, then in the place of tannin you can use chromium salt, because chromium salt also have charge. Next example I am telling you, means all are the applications. All applications I am telling you. The next application is this thing, cleansing action of soap and detergent. Already I have discussed in details. Next application is in photographic plates and films. Okay, in photographic plates and films it is used. Photographic plates or films are prepared by coating an emulsion of the light sensitive silver bromide in gelatin over glass plates or celluloid films. Again I am telling you, this photographic plates or films are prepared by coating an emulsion of the light sensitive silver bromide. Silver bromide is actually light sensitive, and I want to tell you more about the silver bromide. That sunglass you might have used also. Okay, then also called photochromic glass. Then just to protect, it protects from the sunlight. Okay, it protects eyes from sunglass. In that photochromic glass, in that glass this silver bromide is used. Okay, this silver bromide is used. This silver bromide actually, when it will come in contact with sun, then it is actually present in the glass. Then when it will come in contact with the sunlight, it vaporizes. Okay, it converts into the vapors. It will spread inside the glass, and you will feel cloudy. Light effect will be less. You will feel dark. Then it will save you, or it will protect you from sunlight. Okay, then this is also due to colloidal action. Okay, then this I have told you, photographic plates and films I told you. Now this other application I was telling about the silver bromide in gelatin. Actually here photographic plates, this is used in photographic plates or films. It is used in photographic plates or films. These photographic plates or films are prepared by coating an emulsion of the light sensitive silver bromide in gelatin over glass plates or celluloid films. On that silver bromide is used. Okay. Now next application is in rubber industry. In rubber industry, latex, L-A-T-E-X, latex, you might have heard the name. Okay, latex is a colloidal solution of rubber particles. Okay, rubber, from the rubber actually latex is formed. Then latex is a colloidal solution of rubber particles which are negatively charged. Rubber is obtained by coagulation of latex. Okay, from the latex this rubber is formed. by coagulation. Then in rubber industry it is used. Okay, latex is a colloidal solution of rubber particles which are negatively charged. Rubber is obtained by coagulation of latex. One more application I am telling you, that is the industrial products. Industrial products, as for example, paints, inks, synthetic plastic, you can tell synthetic plastics, rubber, graphite, lubricants, cement, etc. are colloidal solutions. Again I am telling you, industrial products, paints, because question is asked, you should remember, paints, inks, synthetic plastics, rubber, graphite, lubricants, cement, etc. are colloidal substances. This I have discussed application. Okay, and now this chapter completely finished. Surface chemistry completely finished. Next class I will start new chapter. Thank you.